You are watching Cold Fusion TV.
Hi, welcome to another Cold Fusion video. This video is going to be something a little bit different. It's pretty exciting and frankly amazing. For the longest time, it was thought that brain damage, such as that caused by a stroke, is permanent and irreversible. But a recent medical breakthrough is bringing this notion into question. Researchers at Stanford University have been blown away by the results of a clinical trial they conducted. Among other amazing stories, a wheelchair-bound stroke victim has regained the ability to walk after stem cells were injected directly into the brain. It's all pretty crazy, but in this video, we'll take a look. As defined by the US National Institution of Health, a stroke is a medical condition in which poor blood flow to the brain results in cell death. Stanford University tested a new method for recovering damaged brain tissue. The surgical procedure involved 18 stroke patients that were at the plateau stage of recovery. At this stage, there's typically no more potential for recovery in motor coordination. That's pretty much it. That's the best it's going to get. They're usually taken out of therapy because it's believed that their brains have been damaged in key areas beyond repair. During the trial, surgeons drilled a hole into the skull of the patients and injected human adult stem cells around the damaged areas of the brain. Amazingly, these stem cells then triggered the damaged areas of the brain to repair themselves. Within days, patients could move limbs again and begin to speak properly when they couldn't previously. They could even be sent home on the same day as the surgery. Here's a news report from CBS on the topic. It is amazing.
We have some remarkable video to show you tonight. Stroke victims making incredible progress literally overnight thanks to a new kind of treatment at Stanford.
5 years ago, Sonia Kuntz suffered a stroke that severely damaged her brain.
This is Sonia's stroke.
It partially paralyzed Sonia on her right side, and she could barely speak.
Her speech was not very understandable. She couldn't order food or communicate well.
2 years later, Sonia could still hardly lift her arm, but just one day after an experimental treatment,
Oh my gosh.
Sonia could lift her arm over her head.
Can you move it to the side?
And move it to the side.
Are you kidding me?
And also to the front. And her words began to flow.
I woke up and immediately I could speak better.
Dr. Gary Steinberg, chair of neurosurgery at Stanford, led the small clinical trial. 18 chronic stroke patients were involved. 12 came to Stanford, including Sonia.
I was very excited. I think I started to cry.
In the trial, Steinberg drilled a tiny hole into the patient's skull and using a very fine needle, injected modified human adult stem cells around the stroke.
We put them around the stroke, and that's where they do their thing to recover the function.
These cells don't survive for long after the surgery, but they appear to trigger a patient's damaged brain to begin to heal itself.
The cells somehow jumpstart the system again.
Here's another stroke patient just before surgery. And here she is just days after receiving the stem cell treatment. As for Sonia, her life is back on track. She's now married and pregnant with her first child.
And it's a boy. Yeah.
According to Gary Steinberg, chairperson of neurosurgery at Stanford, one of the patients was a 71-year-old wheelchair-bound individual who could walk again after the stem cell surgery. This event shocked everyone on the research team. Quote, "Their recovery was not just minimal recovery, like someone who couldn't move a thumb and now being able to wiggle it. It was much more meaningful. One 71-year-old wheelchair-bound patient was walking again." He goes on, "This could revolutionize our concept of what happens, not only in stroke, but traumatic brain injury and every neurodegenerative disorder. We thought the brain circuits were dead, and we've learned that they're not." End quote. So Gary seems to hint that stem cells could be used to treat other neurodegenerative diseases like Parkinson's or Alzheimer's. Alright, so that's all well and good, but let's dig a little deeper. What exactly are stem cells? Stem cells are a very remarkable type of cell. They have the ability to change themselves into any other type of cell during early life and growth. In tissues, they serve as a sort of internal repair system, dividing essentially without limit to replenish other cells as long as the person is alive. They can even do this after long periods of inactivity. When a stem cell divides, each new cell has the potential to either remain a stem cell or become another type of cell with a more specialized function, such as a muscle cell, a red blood cell, or in this case, a brain cell. In some organs, such as the gut and bone marrow, stem cells regularly divide to repair and replace worn-out damaged tissues. In other organs, however, such as the pancreas and heart, stem cells only divide under special conditions. The cells used in the Stamford surgery were SB623 stem cells. These cells are actually a product of Sandbayer Incorporated. SB623 are bone marrow-derived stem cells from adult donors. The new idea here is that these special stem cells have been genetically engineered to repair damaged cells when introduced. According to the World Health Organization, 15 million people suffer strokes worldwide each year. Of these, 5 million die and another 5 million are permanently disabled. Once knowing this, it becomes easy to see the huge potential of this medical breakthrough. Right now, the Stamford team is now moving into phase 2 of the trial with 153 patients on the list. They're going to see if these results can be replicated. I'm definitely wishing Gary and his team all the best. I personally think that this is really awesome to see. These are the very early days of stem cell genetic research, and the technology can only get better from here. Clearly, a huge potential lies within stem cell genetic engineering. It definitely can be used for good, and it's nice to see this technology being used in that way. As a side point, a lot of this just shows how little we know about the human brain, and in a way, we tend to take it for granted every day. So what do you guys think? Let me know your thoughts in the comment section below. Anyway, I thought I'd just bring that story to you guys. So thanks for watching. If you're new to this channel, feel free to subscribe. This has been Dagogo, you've been watching Cold Fusion, and I'll see you again soon for the next video. Cheers guys, have a good one.
Cold Fusion. It's new thinking.